Okay, so we're aiming for 33 kilometers, which is actually completely doable using one of these solid rocket boosters, which we actually need to test. So yeah, let's set this up. We're actually going to put some payload on this to reduce the mass a bit, or increase the mass a bit and reduce the acceleration. We are going to have one of these Rockomax engines, but between these we're going to have a decoupler. The TR-18 stack decoupler that will detach the two things into two separate pieces, and hopefully they will land safely. I'm going to add some landing legs to this because these materials research bays are actually very fragile and will frequently break. I'm going to add some parachutes to this. Now these will fire when they're in the same stage, when they will fire even in the same stage as the decoupler. So what I'm going to do is decouple and then the parachutes will fire simultaneously. So ideally all of this will land safely. Oh, very important is this thing puts out a lot of thrust and is designed for pushing a lot of things, but if I cut the thrust down to about 50%, we should do just fine. Now the last thing I want to do, I guess, is swap out the crew there, put Bob Kerman in there and launch. Now you'll notice that remembers that Bob Kerman, he was on one of the previous missions. Okay, so ready? We don't need to throttle, we can throttle down to 0. Stability control does not work because of course he is a scientist and scientists don't know how to steer. Now first thing, on the way up just above the Space Center we'll observe the materials bay, doing science. The less resilient samples appear to have splattered around the interior, forming new and interesting colour combinations. That's great, and we don't need a crew report here because we've already got all the crew reporting we could possibly need from this. Okay, so we're going to accelerate upwards and our velocity will increase. You see this surface velocity, that's what that's saying is that's relative to the surface of the planet. If you click orbit, then it's relative to the middle of the planet, and so you're going faster in orbit because the planet itself is actually rotating relative to the center. Anyway, what happens is that the fuel in this will burn down to 0 and I will continue to coast upwards, decelerating at 1g. Now there's an easy way to figure out, assuming you're decelerating in a constant g, you can actually figure out how far you will go quite easily, not accounting for aerodynamic drag. So if you're moving at say 400 meters per second, then you divide that by the force of gravity. So the force of gravity is about 10 meters per second, so that's 40, right? So you then multiply 40 by 400, which is 16,000, right? And then divide that by 2, which is 8,000. So 8,000 meters is how far you'll go if the engine's cut out when you're moving 400 meters per second. So ready, 600. Okay, so in the absence of aerodynamic drag, we expect this thing to go up, well, 6 times 6, 3,600 divided by 2, 1,800. You know, I think we should be able to do this. Let's just see. So we're going to collect more data while we're up here. And I'm going to deploy the landing gear. The rarefied air has caused interesting changes to the gel samples. It seems like something is happening with the internal structure. Well, let's keep that data. Now, I'm hoping that that thing will remain within 2.5 kilometers, because if it doesn't, then it will magically disappear and their stage recovery attempts will be for nothing. There we go, look, 33 kilometers and not much else. So we have completed the altitude record. We've tested the Rockomax, we've set our other altitude record, and we've tested that. Look at this, see? What a nice little thing. Now, the danger is, or the race is on, can we catch up with this thing? One would imagine no, because it's falling faster away from me, I guess. And it's also falling, I guess it's falling through thicker parts of the atmosphere, so I might actually catch up on it, hypothetically. It'll be interesting to find out. As I said, if it goes beyond 2.5 kilometers, the game will remove it, and then once that happens, you lose it. There are mods which will let you recover the cache value. If it sees that it's on parachutes and is falling through the atmosphere, it will then give you the appropriate recovery value, but by default the game does not do that. Okay, see, now I'm going down and I'm hoping this will start to decrease because he's ahead of me. and he is falling through thicker atmosphere than me, therefore I should be going just a little bit faster coming back down. And he's also in parachutes. There, you see, now it's starting to decrease. So what I should do is when I come down, let's deploy my parachute, and hopefully we shall sink to the ground together in harmony. Actually, this is coming up really, really fast. Look at this. He's really zipping by there. Look at that. Yeah, we're flying by that. Now, that expended booster may be a lot taller and a lot larger than the spacecraft, but it has burned most of its fuel, so it's going to be a lot lighter. The aerodynamics probably doesn't model it correctly. In fact, I know it doesn't model it correctly. There are mods for that you want, but yeah, there it is. It should. The trick is now, I hope that I don't fall so much faster than it that I move more than 2.5 kilometers away from it. I don't think that's going to happen. Because we're now within about 4 kilometers of the surface, and the velocity or the distance isn't increasing as quickly as I'd like. We are getting down low towards the surface, and from here we should probably grab a crew report. Hey, I can see my house from here. Yes, we got some more data. 1.7 kilometers, but 1 kilometer to go before the parachute opens, so we are definitely going to stay within range. From here we can sit and, you know, appreciate the marvelous view that we have here. It's entirely possible, incidentally, for spent stages to come and crash into you. I have had it on very rare occasions, and it is one of the funniest things ever when it happens. But yeah, we can appreciate the great view. There's the moon. The planets and everything will render correctly. And the parachute opens. It's about 380 meters away. Oh, and the distance is increasing, which means we are actually falling slightly faster than that booster, which has 2 parachutes on as opposed to this one. That's actually good because we have the landing legs to absorb the force of the landing, and that should actually mean that we're trying to protect these materials studies bays, because those are actually pretty fragile, and landing on them can quite easily destroy them. So the landing legs will help us in this case. And touchdown, and I folded it over that way simply to make sure that I landed on my back correctly. Now, to switch to the other object, we can use the bracket keys, the square brace keys up next to the P key. So I click on these, or push the button, and I switch over, and now I can observe this spacecraft. Of course, this does not have a pilot, it doesn't have a probe. I can't actually do much with it. I can move the camera about, I can time accelerate as I watch it land, and I'll slow down as it touches down, and we have successfully recovered both of these vehicles. So let's go back to the command center. And it tells us we now have another 40 science. We collected all these parts. Our crew is happy. And if we turn the camera, we can actually see that here. Now, if it was further away, you can go into this tracking station, and the debris, click on that, and then recover it from here. So that's how you find hardware that's elsewhere in the planet, or in the entire universe, actually. Okay, so we're now doing pretty well. We've got 74,000. We're getting close to going for space. And in fact, there are no more height records to be had. We have escaped the atmosphere. Well, that's what we're going to do. And we could go for orbit Kerbal. That's a pretty good goal, actually. Orbit Kerbal. And so that gave us a pile of money. Now what I'm going to do right away is upgrade... Oh, not this. I'm going to upgrade the astronaut facility with some of that cash so that I can perform an EVA in space. Secondly, we're going to build a really simple and really cheap orbit-capable spacecraft. We have to have a capsule again, of course. I'm going to put on this kind of fuel tank, a liquid engine. Ooh, liquid engine. I'm going to put on a couple of goo canisters, but nothing else. Actually, you know, now I think about it, maybe I'll stretch this stage just a bit. There we go. Now, we want to have a decoupler, and we'll have a solid fuel booster here. This is, again, we're going to ditch this bottom stage and solid rocket boosters are actually very cheap, so it's a good way to start. So we're going to lighten the load a little, so I'm going to right click on the command pod and take the monoprop. You want to shrink that down to 0. Don't shrink the electric charge because the electric charge is important and it doesn't weigh anything anyway. You can rearrange your staging so that the rockets fire at the same time as the stages activate. That can help. And the last thing I might put up with this is a rechargeable battery pack, just to make sure we have enough to get us through the flight. There we go. So let's launch this. I'm pretty sure this will go into space. I'm going to fly with Jebediah because he actually has experience and skills in flying. That will make a big difference. Okay, so this rocket is designed to be cheap. It doesn't have the materials bay experiment, you'll notice, but I'm really just trying to, again, maximize the money. So we're using the solid rocket boosters. Those are cheap, they're expendable, they provide a lot of thrust to mass, but their specific impulse, which means their fuel efficiency, is actually really, really lousy. They give you a lot of thrust, but they really don't burn for very, very long. So I'm going to burn through 2 of these stages, and then I will kick into action the upper stage, which has a rocket. We're just going to go straight up with a very slight bank over here towards the 90. Now you want to make sure for your first orbital attempts you're going towards the 90 degrees orientation on the nav ball down below. You don't want to turn over too quickly, and more importantly you do want to watch your solid fuel in the bottom left. The moment that shuts down, you got to switch to the next stage. Bingo. Okay, so we're going to continue climbing upwards. This upper stage only has the tiny LV909 engine that doesn't deliver enough thrust when it's empty to actually overcome the force of gravity. So we actually want to be moving upwards pretty quickly, which means I'm not turning over this rocket as quickly as I might turn over other rockets. You know, you're going to figure this out with various designs. If you find this rocket hard to fly, you can build something that has much more liquid fuel and bigger liquid fuel engines. Liquid fuel engines are more efficient and they are throttleable. This design I'm doing specifically because it's cheap and it's kind of small, so that when it lands, in theory, we should be able to recover most of the spacecraft, whereas a larger rocket, say that was much longer, you might be throwing away more of those expensive parts. So I'm just thinking in terms of the recovery equation here. So I'm continuing to fire my engine roughly along the velocity vector here. When you're firing along your velocity vector, you are getting the maximum efficiency from your engines, right? This is your what's called steering losses. If you have to steer away from your velocity vector, you are actually losing fuel efficiency, essentially, based upon the cosine of the angle between your pointing vector and your velocity vector. But as I pass 25 kilometers, it normally switches over automatically to orbit here. So orbit is now 600, we're now moving at 600 meters per second. You'll notice that my velocity jumped up the moment I clicked to switch over from surface to orbital velocity, and the reason is surface mode includes the rotation of the planet. So when you switch to orbital velocity, it doesn't include that, or it doesn't subtract it. You suddenly get the bonus from the rotation of the planet, which is about 175 meters per second. Anyway, as we get closer to orbit, it's useful to have the map helping you figure out your apoapse. It'll give you a plot of your orbit. So press M, and then at the bottom you have this little tab that shows the nav ball. You see you can fold it away and bring it out. Generally you want that out. This helps you fly the spacecraft from the map mode. So I'm continuing to burn sideways. Ideally, you want this apoapse thing, which I'm mousing over, you want that to go above 70 kilometers. That will be outside the atmosphere. You can mouse over your spacecraft to see your current altitude. And more importantly, you want the distance between these things to be growing. If it is not growing, then you are going too shallow. Your spacecraft is not thrusting fast enough, or its attitude with respect to the horizon is too shallow, and you could find yourself falling back towards the surface. Not that falling back towards the surface is instantly fatal, because real rockets actually do this. Anyway, yeah, we want to get it above 70, ideally nearer to 80. So 70 is of course outside the atmosphere, so that's me successfully. If I just cut out now, then I will succeed in escaping Kerbin's atmosphere. But if I if I get up to that altitude, I can then fire my engines there, so to circularize the orbit. So let's wait this out. We're still doing fine. Gonna wait until it gets up to about 80. You want to get it high enough that you have a decent margin for error here. There we go. It's 79 kilometers. And we have a decent amount of fuel left in the tanks. In fact, we might have enough fuel left in the tanks to go even higher. But on your initial orbit, you should aim to get close in. The reason being that if you overdo it, you want to make it easy to get back to the surface. So I use time acceleration again, using the little greater than, less than keys to put myself close to this, and then I line up with the horizon between the blue and the orange and throttle up my engine. I keep my spacecraft pointing there, and what you see is the orbit circularizes and pops out the other side, and at some point these things flip, and that is you have attained orbit. Yeah, you've attained orbit using a super cheap spacecraft. That's brilliant. So you should actually have got a decent amount of cash for this. Now, because I upgraded the Space Center, I will be able to do EVAs and stuff in space. But let's fly around the planet using time acceleration so I can get into daylight, so I can appreciate the beauty of the planet Kerbal from orbit. There we go. So let's turn this around so that we can so that the hatches on the side, that helps. And yeah, let's do a mystery goo experiment. Observe mystery goo. The goo seems to have clumped into a sphere. It also appears to have become brittle. Well, okay, that's very interesting. Now, as soon as I step out of the capsule, so I can do a crew report. It seems we are very much in space right now. The sky seems to be mostly below us. So that's one crew report. We can now EVA because I have upgraded the astronaut building. And as soon as I click EVA, I end up on the ladder, which is of course very nice because I can now do my usual things of taking the data from the capsule and storing it back inside the capsule, and I can do an EVA report. You've recorded your observations about the situation, and this is from space just above Kerbal's water. If you are in low orbit above a planet, you can get EVA reports from the various biomes. So just by staying in orbit, I will be able to get EVA reports from low orbit over multiple locations. Now, I can also grab the science from these goo canisters, and you'll notice, incidentally, that the spacecraft is rotating. You have to be very close to the canister to collect the data. It's good to collect the data and put it inside the capsule. The reason is you're more likely to destroy a bit of your spacecraft than you are the capsule. Yeah, so the spacecraft picks up a rotation, the reason being, as soon as you leave the capsule, the SAS system has gone, so the spacecraft will rotate. And the physics system is a little dubious about this sometimes. You will find that walking up and down the ladder can adjust your orientation. Okay, so I've time accelerated, and now since we're over land, I should be able to EVA and do another EVA report. Yes, we collected data from just above the Highlands. So of course I can store that and get back on board and maybe travel a little further and then collect more data. This is a really great way of collecting extra data early on. Not every experiment lets you collect the different biomes. The biome dependability is altitude dependent for different experiments. So EVA works into low orbit. There is the Gravioli detector will provide different biome data regardless of altitude in low orbit and high orbit. Some of the stuff will just provide data based upon altitude, such as the goo canisters that are attached to this. You need to experiment with the different experiments to figure out what you're doing. So I'm just sitting here and I'm watching myself fly across the surface at about 2 kilometers per second, and I'm trying to collect data on new biomes. Look at us, quietly, almost silently slipping over the surface of Kerbal, exploring new regions by, well, hanging out in space and looking down upon them. And a few minutes later, we finally have moved over the grasslands. I've recorded the observations on the situation. Yes, there's a lot of data to be had, and you should absolutely exploit it. Anyway, while you're in orbit, you can also go back to the Space Center, and moreover, you can go back to Mission Control. You've completed 2 contracts, which means you can pick 2 more. There's some things that you might want to pick to enhance this mission. For example, it does have a Mark 16 parachute on board. However, getting it down to that velocity at those altitudes is highly unlikely. However, test the LV-909 liquid fuel engine splashdown at Kerbal. Well, you know, the amount of money available for this isn't much, but if we can land this spacecraft in the water, we can absolutely do this mission and complete it. So it's essentially free money. You just have to kind of look through the missions and figure out if you can take advantage of any of these. Another example would be some of the survey missions are supposed to be surveyed from above a certain altitude with a certain instrument. Well, you could put a spy satellite into polar orbit and then essentially wait for it to be about to fly over the relevant location. And of course, you know, survey it from orbit. That's a, you know, survey satellite is a legit idea that can actually work. Anyway, there's also different orbit altitudes, and since I have plenty of spare fuel here, I'm going to fire my engines and put my spacecraft into a slightly higher, give it as higher apoaps. We're not going to put the entire spacecraft into a circular orbit, but above 250 kilometers, you can get another science biome. And there we go, 267. We still have tons of fuel left. So I'm only gonna put one side of the orbit up there. It's going to be an elliptical orbit that goes between 80 and 267. And for the brief moment that I am above 267 kilometers, I can collect the extra science, the extra information, and then of course return it. This is just using the facilities I already have without spending more. So I'm going to do a crew report. Crew reporting in from space. We can also do an observe mystery goo mission. Yes, observation while in space. Awesome. And of course, get an EVA. And yeah, once again, things start spinning. When you're flying in space, I should mention the R key gives you RCS control if you fall off your spacecraft, and you can use WASD shift and control to move around your spacecraft. I should have probably mentioned that earlier. The other thing is, L will turn on your headlamps so that you can see what you're doing on the dark side of the planet. I'm going to collect that data. Once you collect the data from the goo canisters, you cannot reuse them unless you have a laboratory on board your spacecraft. This is important later on. In fact, the release of 0.90 finally makes the laboratory a really viable feature to have on your spacecraft, because previously the labs, when you would send them out, you wouldn't have enough biomes to actually collect enough data to justify sending a laboratory along. People would just put them on their spacecraft because they were kind of a cool thing to have. Anyway, to return, we would of course fire our engines retrograde at the highest point in our orbit, and then we would land at the point where it's lowest. The only thing is, because of the rotation of the planet, the Space Center is a long way away, and there's a bonus for returning when you're near the Space Center. So because I need the Space Center to be in a particular location, I need the planet to rotate, which means I need to accelerate time. However, time acceleration in orbit is limited depending upon your altitude. When you're really close in, you can only accelerate at 50 times regular speed. However, in the map screen, there are no such limits, so I can accelerate at 10,000 or 1,000 times normal speed, wait for the Space Center to come around into a position where I think I can begin to think about a deorbit burn, and then fly the spacecraft again. Okay, so now we're going to perform a deorbit burn. What we mean is we're going to go to the highest point in the orbit, and then we're going to fire retrograde. Retrograde is of course the opposite direction to which we are orbiting. If you burn retrograde, it means your orbit slows down and you fall back into the atmosphere. However, I want to fall down over the Space Center, right? So I want to put myself close to the Space Center. Normally you would just burn until your altitude dropped to about 50 kilometers or 40 kilometers. But I want to come down as close as possible to where I want. I specifically want to land in the water next to the Space Center. So by doing this, I think this should actually work pretty well. This is at least my plan. By coming down like that, it means that I'm coming down much more steeply. So by coming down steeply, it means that my velocity, my spacecraft is going to spend less time in the atmosphere getting slowed down. So my landing site should be much closer to my actual landing site. My predicted landing site should be much closer to my actual landing site when I take account of the atmosphere, because we're falling through it very, very quickly. At least that's the plan. We'll see if it actually works. Okay, Jebediah Kerwin, we're now falling towards, and I think, you know what, I think I might have overburned a little. I still have plenty of fuel left. There's a pretty good chance that I am gonna not make it to the ocean on the far side of this peninsula, so, and actually, given that there's mountains and stuff in the way, more likely to hit the mountains. Yeah, look, 39 kilometers up, I'm probably... Okay, I want to slow down now, actually. And I'm not slowing down fast enough. I think I'm going to end up on the land. So my contract, my test contract that I accepted was test the LV-909 in the water. Not going to happen. Instead, I'm at least going to try and land this thing safely on the LV-909. The parachute has been deployed for stability reasons. You don't need to worry about the flames during re-entry. That is only a cosmetic effect at this time. In future versions, it may be deadly, but there's no problem deploying your parachute when the rest of your spacecraft is on fire. If you really want re-entry to be deadly, there is a mod which is conveniently called Deadly Re-entry, and Deadly Re-entry will make sure your re-entries are deadly. You see, it does what it says on the tin. Now, while the re-entry may not be deadly, the landing might actually cause some damage. So we're landing this whole spacecraft on a single parachute, and our descent velocity... Okay, right now we're descending without the parachute fully deployed, but when it deploys, our descent velocity will probably be about 10 meters per second. Let's see, 12, 11. Okay, so when I get down close to the surface, and I'm using time acceleration here, I want to fire the engine at not 100% thrust, but enough to slow my descent down to about 5 meters per second. Plenty of fuel to do this, so it shouldn't be too hard. Okay, I was going to say it shouldn't be too hard, but clearly I can't even do this. Worse, I actually managed to land myself face down, and I couldn't get out of the pod to perform extra science. So, yeah, I pretty much had to just recover the vessel and forget about collecting more science. All the same, that quick jaunt into space has brought me a bunch of funds. It's brought me... Well, we've got money left over from the advances, and Jebediah Kerwin has got another experience point. So with 194 science, the most obvious thing to go for is another science instrument. We have the Too Hot thermometer and the lab. We have 104 science left. And, well, stability is a very good thing to get because it adds the radial decouplers. Now, we could get flight control, or we could get one of these other options here. Flight control is a nice one because it adds probes. Probes are kind of good for certain mission types, however, they run on battery power, and the only way to recharge them is with photovoltaic panels, which I don't have the skills for, or I don't have the science for. 86.1 science. I mean, some of the other options are halfway interesting. Actually, that's not interesting at all. This is the most interesting one, but a probe body isn't much use without a solar panel. So, well, you know, as I mentioned, there is science scattered all over the Space Center, and we can go out and find some of it. So, to get 4 science is pretty easy. I can take my command pod, and I can stick all the experiments we haven't run on it. We can stick on the materials bay, and we can stick on the Too Hot thermometer. And that's great. We should be able to launch this, and I say launch with, you know, finger quotes here. All we need to do is run the experiment, run that, and materials show signs of change, blah, 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 and we perform a temperature scan. And it is just a temperature scan of the launch pad, but it should be enough to push us past that 90-point mark and get that. Now, I'm sure if I wanted, I could run around the Space Center and get a whole 45 other science to get the probe cores, but I think this is a pretty good place to leave it here. Hope you've learned something. I'm Scott Manley. Fly safe.